All right, let's see. Question number 1. On volumes of solids with known cross sections, it says the base of a solid is bounded by y equals cosine of x, the x-axis, and negative pi over 2 to positive pi over 2. Okay, so graphically, negative pi over 2 to positive pi over 2. The x-axis and the graph of cosine x. Okay, so cosine x, we know hits here. The cosine pi over 2 is 0. The cosine of negative pi over 2 is 0. And we have an idea of what a cosine graph looks like. Okay, so our cross sections are going to be perpendicular to the x-axis, and they are going to be squares. So I'm not very good at drawing this, but I will give my best shot here. So perpendicular to the x-axis, and it needs to be a square. So that kind of looks like a cross section. Drawing a few of these, except that they are supposed to be squares. So I should make them look more square-like. Okay, so we need to think about how to find the area of one of these squares. So since it's a square, the area will be side times side. Or side squared. And the length of the square would be this, or this, or this, or this. It changes based on x, and all of these values are the y value for that x value. And so that's where it's helpful to know that y is coming from the cosine of x. So therefore the side length of each of these squares is cosine x. So the area of each of these squares would be cosine times cosine, or cosine squared. Okay, so for the volume, because we would like to know the volume of these cross sections, we can integrate. Here's our two bounds. So some questions we have to put some thought into what the bounds are, but this question bounds are given to us. And so you can think of this as like a length, and this is a width, and this is length. Cosine squared x is like a length times a width, and a volume is going to also have a height. But since each of these squares is infinitely thin, the way that we keep up with that is the dx. So it's kind of like it's the width and this is the length and the height. It'd probably be better. Let's call this height. And then so this is like the width. So this is why it's volume. Width, length, and height being multiplied together. Now I can go to my calculator. Sometimes we can integrate by hand. I'm going to let my calculator do this one for me, just save a little bit of time. And that tells me it's about 1.571 as a decimal. And if I compare that to pi over 2, pi over 2 is the same thing. So that's where that answer is coming from.